Welcome back everyone. Now we are going to learn about what are the deciding factors that decide the conductor, insulator and semiconductors as we have seen in the last one. So let's get into the technical details. So in the technical details there is nothing so much very much thing. Okay, let me clarify this thing. I'm just drawing two things and you will get understand all the concept in just two factor. There is something called as nucleus. No matter how many layers are there in between, I'm removing for that to have a clear understanding for now. So there is nucleus and this is the electron in the last cell. So why this cell? Well, I'm going to explain that in a while. So this is our electrons. uh, Surely there are four electrons, but to ease of the understanding we are just considering one electron at a time. So this is one electron and this is known as valence shell. So the shell is named as valence shell, and you can also call it as valence band. So the band is the word here, and this is going to change so many things. Now what will going to happen if this electron is going to get excited and jump from this place to this place? So this is not technically the orbit of the nucleus conduction, but this is called as conduction band or conduction cell. So what is the meaning of the conduction band or conduction cell, and why it is so important? Why I'm considering and focusing so much upon this one? So to travel this distance, as we know, we require some energy, and you can call it as energy gap, writing with EG, energy gap, or this level is also known as Fermi level. So these are just the same names for the different thing. No, actually different names for the same thing is the right word here. So this is the Fermi level in which you can understand that there is a gap, and that gap is going to decide that what is conductor, what is insulator and what is semiconductor. So let's learn that. So the gap between the valence band and conduction band in the conductors are the least one. Let's name it F1. Now the insulators have more gap, like this one. Here is our electron, and in this one I didn't mention it, but you can surely understand that this is the electron. So this is the valence band and this is the conduction band, and the electron will surely decide to get excited, but it cannot travel to this range, and let's name it F2. Now midway between there is something that the electron is here, and this is again the valence band and conduction band, and it can reach close to this point. So as I think you have already know to these things, this is our conductor that can conduct the electron from valence band to conduction band, and this is our insulator that cannot conduct no matter how much hard it try, but you cannot make it a conductor. It is in midway between, so if you help it enough, it might have a possibility that the electron will jump from this place to this place. So this is our F3, by the way. So the level or the gap or the Fermi level, whatever you call it as, like we have named it here, electrons need to jump. So when the electron jumps from this state valence shell to conduction band easily, or there is a less gap, it is known as conductor. When the gap is very much more, it is known as insulator, and when the gap is enough but it cannot reach without any help, that is known as semiconductors. So that gave you a clarity kind of things. In the next one I'm going to explain you that what is valence band and conduction band. So stick with me, take care.